Imagine a worker that never stops, never asks for a rise, and learns a new skill just by watching a YouTube video. For decades, that was the sci-fi promise that was always 10 years away.
And for decades, the reality was much clunkier. We got mechanical arms bolted to factory floors and little plastic discs that got stuck under our sofas. It wasn't exactly the robotic uprising we were promised.
But something shifted in the last 24 months. The brain of the robot, the AI, finally caught up with the body. We have moved from laboratory demos to $1 million pilot programs. We aren't talking about it anymore. We are talking about unit shipped and monthly subscriptions.
We've seen these hype cycles come and go, and I'm still waiting for a robot that can fold a fitted sheet without a software crash.
Today, we're looking past the viral dance videos to see how humanoids are actually entering the workforce, from the humble to the 57 billion chip empire of Nvidia. We're breaking down how robots are finally learning to navigate our messy and predictable world.
Welcome to the AI Brothers podcast. We are two brothers who've been discussing technology since we were kids and have decided to include you in these conversations.
We will cut through the noise to bring you data and research on the latest development of AI. And we're not interested in hype. We bring you the signal to keep you on top of this new technological and industrial revolution.
Because AI will permeate everything and be everywhere, initially as a layer on top of existing systems and then becoming itself the operating system.
Okay, before we even touch words like word models and reinforcement learning, I want to make something clear. The conversation has shifted. For years, AI and robotics felt like research, demos, conferences, papers, hype videos. Today, it's becoming a market story with real economic stakes.
Market story means investors, it means pricing, supply chain, labor, things that affect everyday business and economies.
Exactly. Take Nvidia, for instance. Their third quarter fiscal 2026 earning hit a record of 57 billion, up 22% from the previous quarter, largely driven by surging demand for AI chips like those in their Blackwell platform. When companies like Apple, Microsoft position AI as a fundamental platform shift, Apple recently appointed a new AI chief with the experience from Google and Microsoft to accelerate their efforts. And Microsoft expanded partnerships with Anthropic and Nvidia for AI enterprise. These systems are no longer just ideas. They are being forced in the real economy, influencing everything from stock prices to global supply chains.
Or it means investors are projecting fantasies onto unfinished technologies, pouring money into hype without any proven returns.
That happens too, no doubt. But the key difference now is timelines. Companies are no longer saying someday, they are saying early customers, pilot programs, monthly fees. For example, humanoid robot makers are rolling out beta tests in warehouses and homes as we speak, with market projection estimated the global humanoid robot sector to grow from 0.6 billion in 2025 to 6 billion by 2030.
Yeah, at a 50% CAGR is pretty impressive. Okay, let's ground this in something people actually understand. Let's start with some basic stuff like robot vacuums, okay?
Vacs like iRobot's Roomba series are probably the most successful consumers robots in history. iRobot has sold over 40 million home robots worldwide since their inception, and millions of homes already trust them to run freely while nobody is watching. Despite recent revenue dips, they've normalized robots in daily life.
Yeah, well, they vacuum, sometimes mop, return to their dock, empty themselves, basic stuff, but reliable. For many people, that's good enough.
They use a combination of cameras, LiDAR, infrared sensors, wheel encoders, and basically machine learning to map rooms and avoid obstacles. Early models were simple, bump and turn devices, but now they employ location and mapping algorithms to create detailed home layout and even recognize specific rooms or no-go zones.
Yeah, I mean, they're nice, but nobody claims that they are intelligent. They're more like automated tools than thinking machines.
That's the lesson. They are useful, not smart. They do not replace human cleaners entirely. Instead, they remove the daily friction. Floor, Floors stay cleaner with less effort, saving people time on mundane tasks. Studies shows that households with RoboVacs report 20 to 30% less time spent on floor cleaning, even if robots aren't perfect.
They, yeah, but they also fail in like annoying ways. They get tangled in shoelaces or cliffing off stairs if the sensor glitch. So even these basic robots are still nowhere near an autonomous creature.
Yeah, absolutely. They get stuck on cables, misidentify objects like pet waste as debris, or avoid areas unnecessarily due to lighting changes. But people tolerate that because the value is incremental. It's not about perfection. It's about consistent small wins that adds up over time.
So let's ground this a bit in history. So robots have existed for a long time. So you had early mechanical arms in factory dating back to the 1960s. So why has progress stalled for so long?
Because robotics try to overthink reality, engineers attempted to describe the world with rigid rules. If the object is this shape, do this. If the floor is slippery, do that. This rule-based approach popularized in the 1970 and 1980 with systems like Shiki, the robot at SRI International, relied on exhaustive programming for every scenario.
Well, yeah. Well, reality doesn't cooperate. The world is full of variable, uneven surfaces, unexpected obstacle, dynamic environments.
Exactly. Homes are messy. Lighting changes constantly. Objects move around, and humans behave unpredictably. Rule-based systems collapse under that complexity. They suffer from the frame problem in AI, where anticipating every possible change becomes impossible. Early robots broke down frequently due to hydraulic leaks, failing control with systems with 9060 electronics, or degrading programming memory. Human errors in interaction, like incorrect inputs, also led to failures.
So the shift was letting robots learn instead of obeying rules, adapting through experience rather than predefined logic.
Yes, learning accept uncertainty. It assumes that the robot will be wrong initially and improve over time, much like how children learn by trial and error. This paradigm shift started gaining traction in the 1990s with probabilistic robots, but really accelerated with the modern machine learning in 2010.
Okay, so now let's move fast forward. Let's talk about the modern day. So we hear reinforcement learning. Let's explain it without equation or jargon overload.
Think of reinforcement learning or RL as behavior shaping inspired by psychological concepts like operant conditioning from B.F. Skinner. A robot takes an action in its environment. The environment responds, and the robot gets feedback, positive or negative rewards.
Good or bad, it's like training a dog with treats.
Yeah, exactly. If a RoboVac cleans a room efficiently without collisions, that outcome is rewarded with a high score. If it bumps into furniture or wastes time looping in cycles, that outcome is penalized. Over repeated trials, the algorithm adjusts to prefer actions that maximize rewards.
So over time, it prefers actions that lead to better outcome, like optimizing paths in a warehouse.
Real-world examples include Boston Dynamics robots learning to walk on uneven terrain by simulating falls and recoveries, or automated trading bots that learn stock patterns through simulated trades. But here's the catch. Physical experience is slow and costly. A robot cannot fail millions of times in your living room without breaking things on itself.
Which limits how much it can learn in the real world, forcing reliance on simulations.
Unless you find a way to learn without constant human supervision, like combining RL or reinforcement learning with vast simulated data sets to accelerate training before real world deployment.
Okay, so now this brings us to companies like 1X Technologies.
Yeah, exactly. For years, humanoid robots were trained through teleoperation. Humans wear VR headsets or motion capture suits and remotely controlled the robot, demonstrating tasks in real time.
So the robot records every moment, every decision.
It's like teaching by demonstration. They works well for basic tasks like picking up objects, opening doors, or folding laundry. 1X has used this with their new robot, which stands 5 feet inches and can perform household.
But it is extremely expensive, requiring skilled operators.
And physically demanding. Some workers reported repetitive strain injuries from long sessions. Wages often start around $24 an hour, and training complex tasks requires thousands of hours per robot model. One ex-CEO has noted they're shifting away from heavy reliance on human teleoperators toward more autonomous systems.
Yeah, because if you're relying on a human trainer, it just makes scaling impossible for mass production.
It also limits diversity of experience. The robot only sees what humans show it, missing edge cases like unusual object placements and environmental variation that aren't demonstrated.
Okay, so basically from there, we're again continuing on our flow of history. So now companies started talking about word models. And so let's talk. What are they really?
A world model is an internal representation of how the environment behaves, built through AI. The robot doesn't just react blindly, it predicts outcomes based on learned physics and patterns. Nvidia describes them as generating photorealistic synthetic data to help robots develop spatial intelligence in simulations.
But predict what exactly? Like forecasting a ball's trajectory?
What will happen if it moves an arm, pushes an object, or walks forward? It learns cause and effect from data, such as video feeds. One X own world model uses a text-conditioned diffusion model trained on web-scale video and fine-tuned on robot data for self-learning.
So instead of copying human directly, it experiments safely in a virtual space.
Yes, it learns from its own camera feed and sensors. Over time, it builds intuition about physics, motion, and interaction, reducing errors in real-world deployment.
That sounds like common sense, but applied to machines.
It is machine common sense, not human level yet, but enough to reduce dependence on teleoperators, allowing robots to generalize to new tasks without constant retraining.
Okay, so now let's talk a little bit science, and we wanted to discuss a recent paper, and this recent paper on the VLGPA becomes very relevant in this discussion, isn't it?
Yeah, VLGPA or Vision Language Joint Embedding Predictive Architecture focuses on predicting meaning instead of generating words or pixels token by token. Traditional models like GPT generated the text autoregressively, which is slow and computationally intensive.
But VLGPA works in an embedding space. Okay, so let's define that. What does it mean?
Think of embedding as coordinates of meaning in a high-dimensional space. Similar situations cluster together even if they look differently visually or linguistically. Meta v JPA to an evolution of this achieves state-of-the-art visual understanding for zero-shot robot control. Jan LeCun, who pioneered JPA, emphasizes its efficiency for online video streaming.
So what does this mean actually for robots now?
So robots experience continuous motion and video input. VLGPA is good at predicting what matters next in a sequence without generating unnecessary details, like focusing on key actions in a video rather than every frame.
So it learns patterns of activity efficiently.
Yeah, cooking sequences, cleaning routines, walking gaits, reaching for objects. These are exactly the patterns robots need to understand and predict for autonomous operation.
This still feel a bit ambitious to go from here to a humanoid robot.
Yeah, it should. But look at Robovax again. Early versions were random bumpers like the original Roomba that just bounced around until it covered the area. Modern ones map homes in 3D and adapt to layouts using AI-driven path planning.
Improvements came from scale, data from millions of users.
Millions of devices collecting anonymized data on floor types, obstacles, and user preferences. Humanoid robots are trying to follow that same path, with companies like Tesla planning pilot lines for Optimus in 2025 and 2026, aiming for million unit capacity.
Deploy early, accept imperfection, like early Robovac that got stuck often.
Yeah, improve through usage, not perfection. Real world data refines models, leading to iterative updates via over the air software pushes.
Okay, so now let's talk about the economics.
The 1X Neo Humanoid robot is priced around $20,000 outright, or about $499 per month on subscription. That frames it like an appliance or service comparable to high-end vacuum or human assistant.
So it makes it accessible but with limitation.
Yes, but with limitation. Early versions still rely on remote human assistance for complex tasks like unloading dishwashers.
Yeah, that seems like mixed autonomy, part robot, part human oversight. It's not looking great.
Exactly. Robot attempt tasks autonomously first. Humans intervene via teleoperation when needed, perhaps through a simple app. Over time, as world models improve, the balance shifts toward autonomy.
Well, but that has also labor implication, like job displacement from manual workers.
Yes, it does. Few operators over time, more robots per human supervisor, potentially one person overseeing dozens. But it could create new roles in robot maintenance and AI training, especially as the market hit 50 by 2035.
What stands out to me from all this is how unromantic this all is. There's no flying car, no sci-fi utopia, just like a robot folding clothes with an operator controlling it. It's not. It lacks the romanticism of future tech.
That's the point. Real technology arrives quietly, solving problems incrementally rather than revolutionizing overnight.
Incremental usefulness, slow trust building, like how Robovac earned their place by being dependable for basics.
Robotics normalize robots in home by being boring and helpful.
Humanoids are trying to do the same, basically, starting with chores like trash pickup or plant watering.
Not by replacing human wholesale, but by absorbing small tasks, folding clothes, cleaning counters, freeing us for more meaningful meat.
Well, I still remain skeptical about the timeline and the scalability, to be honest.
Yeah. And the skepticism is healthy, but for the first time, the roadmap feels grounded in reality, backed by data driven learning, pilot programs, and economic models that prioritize usefulness over hype. That being said, I think we can close the episode. I hope you
Well,
enjoyed learning with us as much as we enjoyed learning with you. We wish you a good and productive day.